Hi guys, today we're going to learn about integration of inverse trigonometric functions. Let's start with the formulas. So the first formula that we have here, it's going to be the integral of du divided by the square root of a squared minus u squared. This one is going to be sine inverse of u over a plus c. Please note something here that it's going to be quite important. A is a number, okay, and then u is going to be an expression, okay. So with this being said, the expectation is that u has x's involved and a is just simply a number, okay. So that's how this is going to look like, and this goes for the three formulas that we're going to see. The next one that we have is the integral of du divided by a squared plus u squared. That one is going to be screen tangent, okay? So it's going to be 1 over a tangent inverse of u divided by a plus c, okay? The third formula that we have for today is going to be the integral of du divided by u, the square root of u squared minus a squared. This is going to be equal to 1 over a secant inverse of the absolute value of u divided by a plus c, okay. Please remember that we're going to use these three and we don't need the other three, and this one we discussed it in the previous class when we learned how to take derivatives of inverse trigonometric functions. So let's start with this example. This example, you can see that the a is going to be 2, the u is going to be x, and then when you compare the situation here with the formulas that you have, you see that the one that it's the same, the one that has the same format is going to be the sine. Therefore, this is going to be sine inverse of x divided by 2 plus c, okay? Moving on to the next example that we have over here, it's kind of like pretty similar but a little bit different. So what you have here is that the same format, this is screaming sine inverse, but you can see that a is 2 but u is 5x, and the derivative of that is not going to be itself, so this is going to be 5 dx. So this 5, we need to divide both sides by 5, okay. So you are going to have the 1 over 5 here because you are missing this guy. So then you have sine inverse of 5x divided by 2 plus c, and that's pretty much what we have. As you can see, the 5x is your u and the 2 is your a in this situation, okay. And this 1 over 5 comes because we need to complete that 5 that we don't have here, okay. Pretty similar to the u substitution what we were doing back in the day, okay. Now the next one that we have over here, you can see that it's the integral from root 3 to 3 of 1 over 9 plus x squared dx. So this one, I can tell you that we cannot use u substitution, because think about that. If you have u substitution, you would have 9 plus x squared, and the derivative of that du would be 2x, which you don't have at the top. That's why we are forced to use inverse trig, because in my brain, and I'm pretty sure in yours, the natural way of thinking this is to do u substitution first, and that's correct, okay, but that's not going to fly here. Okay, so what you have here is that your a is going to be 3 and your u is going to be x. You can see that du is equal to dx, so you don't need to complete anything. It's pretty nice. Okay, you don't need to change the limits of integration. Why? Because u is equal to x, so the limits of integration, they would stay the same. Therefore, what you have here is going to be the following: 1 over 3, because the formula tells you 1 over a, tangent inverse, and then the formula tells you that the tangent inverse is u divided by a, so x divided by 3, and this is going to be evaluated from root 3 to 3, okay? And you have the situation. Now, what's the business? Are we done? No, we need to plug the values. And you know that this is going to be equal to 1 over 3, and then you have parentheses, then you have tangent inverse of 3 over 3 is 1, minus tangent inverse of root 3 over 3. Those two are really nice numbers, because remember from pre-calculus, you know that that one is going to be a beautiful pi over 4. And this one also in quadrant 1, it's going to be a pi over 6. Okay? technically speaking, up to here you would have full score, but I'm just going to, since this is so pretty, I'm just going to make it pi over 12, and then you know that you can multiply that, so you have a pi over 36, and that will be your answer. Okay, so as you can see, it's not that bad. Okay, so let's move on to something a little bit more interesting. Okay, so this one that we have over here, you're going to tell me, hey, I want to use U substitution. Okay, so let's try it. U substitution, U, it would be x squared minus 4x plus 7. Your du, it would be 2x minus 4, which you don't have, so we cannot use U substitution. So the only option that we have here, it's the tangent inverse. Okay, why I know that it's tangent inverse? Because we don't have a square root. Okay, so you're going to tell me, well, I don't have the so-called a squared plus u squared. You are right. So we need to make it happen, and the way to make this happen is via completing the square. Okay, so let's do a mini review of algebra 2. So you have that it's going to be x squared minus 4x, close that parenthesis and put the 7 here. So if you remember from algebra 2, we are looking for this guy and this guy. How can we get it? You are going to divide the negative 4 by 2, which is negative 2, and then square that negative 2, so that's a plus 4 here. If we add 4 here, we need to remove the 4 outside. Okay? That's how we can get the same expression again. So here, you know that this is going to be equal to what? X minus 2 squared, 7 minus 4, that's going to be positive 3. So this expression that we have over here, now it's something that looks better. So you have that it's dx divided by 3 plus x minus 2 squared. Okay? And this one, it's pretty clear that you have a squared is 3 and u squared is x minus 2 squared. With that being said, you can recognize that a is root 3 and u is going to be x minus 2. Okay? So you have that du is going to be equal to dx. Okay? So we don't need to complete any constant here. Okay, so with that being said, you know that this is going to be equal to 1 over root 3, and then you have the tangent inverse of x minus 2 divided by root 3 plus c. Are we okay with that? Now, you can rationalize this, but I'm not going to. Okay, you could rationalize it and it would be correct, but up to here you are correct. For this example, what you have is you need to find the integral of 1 over the square root of negative x squared plus 6x dx. Again, I would do U substitution, and I would see that I'm going to be unsuccessful doing U substitution. You're going to tell me, hey, but that negative in front of the x squared, you are right. That's going to be problematic, but we can fix it. Why? We know how to complete the square. Okay? So, you know that I don't like to have my leading coefficient negative, so let's pull out the negative. So you have x squared minus 6x parentheses, we have something here and something here. Okay? So we're going to complete the square. Take the linear coefficient, which is negative 6 divided by 2, that's negative 3, square it, plus 9 here. Please note that this plus 9 is not plus. It's a negative 9, therefore the one outside needs to be plus 9 as well. With this being said, you can rearrange and you have 9 minus, and then you have x minus 3 squared. Okay? And if you need help with how to complete the square, I have a video about completing the square in my Algebra 2 playlist. Okay? So you can go there and do more completion of the square. Okay? So here you have that it's going to be the integral. Okay? You can put the dx there, and it's going to be the square root of 9 minus x minus 3 squared. Okay, so you have this equation. So at this point you can see that I have that a is going to be 3 and u is going to be x minus 3, which you know that du is going to be equal to dx. With this being said, this is screaming sine. Okay, so it's going to be the sine inverse, okay, of x minus 3 divided by 3 plus c, and you are done with that. Okay, isn't that nice? So completing the square is your friend for this situation. Okay, now let's look at this problem that it's a little bit more interesting. Okay, so this problem that we have over here, we have that it's the integral. You need to evaluate the integral from x plus 2 divided by the square root of 4 minus x squared dx. So So what are you going to do here? If you do the u substitution, let's do the u substitution. U is going to be equal to 4 minus x squared. You know that du is going to be equal to negative 2x dx. Now, you can see that I do have the x, but I don't have the negative 2, which is not a problem because we know that we can divide by negative 2 both sides, and then you can have that here. But the situation that I find here is that this plus 2, that's affecting my entire equation. So since you know how to work with fractions, we can split this as two fractions, as the fractions that we have here. X dx divided by the square root of 4 minus x squared plus, and then you have the integral of 2 dx divided by 4 minus x squared. Okay? So pretty much I just split this into two pieces. Now this one is going to fly with the u substitution that I have here because I have the x. So the only thing that I need to complete here is a negative 1/2 at the front. So this one, you do know that it's going to be the same as the integral of u to the negative 1/2 du. Okay? And this one is negative because it's in the denominator. Okay? You can see that this part is pretty easy to integrate because you know that it's going to be negative 1/2, and then you're going to have that that's going to be u to the power of 1/2 divided by 1/2. So this 1/2's they cancel, so you have that this is going to be negative. Go back to your x's. U is 4 minus x squared, so 4 minus x squared here to the power of 1/2, and then we're just waiting for something plus c. Okay? So on this side, okay, we are done with this one. Now let's look at this one. What's the business here? This one, we don't want the 2. I'm going to pull it outside so I don't forget about it. And then after that, I'm like, that is an arc sine. And you're right. It is an arc sine. What's the pattern here? A is 2, and u is x. Du is dx, so everything flies beautifully. So here you know that this is going to be arc sine, okay, of x/2 plus c. So you can go ahead and put it here. Plus 2 sine inverse, remember that we use both notations indifferently, of x divided by 2 plus c, and this is your answer. Okay, so you can see that it's not that horrendous. Okay, so the key here is to know that you need to split your equation into two expressions. That's it. Okay, now let's look at the next problem, which is very beautiful. Okay, the one that we have over here is going to have like a combo of everything that we have seen today. Do you agree that your natural way of thinking is that u would be x squared plus 8x plus 25? So du, it would be equal to 2x plus 8 dx. Okay? Now, I have almost this because I have the 2x and a constant. But the constant is not what I want. So what are we going to do? This is what my brain thinks. I have 5. How can I make that 5 and 8? So you know that 8 minus 3, are we okay with that? That's going to be 5. Okay? What are we going to do here? You know that this 5 is like 8 minus 3, so I can split your fraction as 2x plus 8 divided by all that monstrosity that we have in the denominator, dx, minus, or you can put the minus here, okay, 3 dx divided by all the monstrosity. You see it? So this part, I'm very happy. Why? Because I know that this one is going to be a u substitution. Do you see it? So this part is going to be equal to the integral of 1/u du, according to this, okay? Which you know that this is a natural log of absolute value of u, and then you have the plus c somewhere there, okay? So this one, pretty much we are done with this part, because we know that it's a natural log. The u is x squared plus 8x plus 25, okay? And close it, and the plus c will be there, okay? Now, the business is, let's look at this one. That one needs more work. What's the work that one needs? Completing the square. Okay? The 3, we know that we can pull it outside. That one is irrelevant. Okay? but this one we need to complete the square. Okay, so you have, let me have some space here. Here I have completing the square. X squared plus 8 space plus 25. Okay, so what are you going to do to complete the square here? To complete the square, you divide by 2, so it's a 4. This is a 16, and this is negative 16. So I have that this is x plus 4 square, and then 25 minus 16, that's a 9. Okay? So I know that this, I can rearrange this expression as the integral dx of x plus 4 square plus 9. Okay? So at this point, I know that this is going to be a tangent inverse. Okay? So you know that this is going to be negative 3 tangent inverse, and I forgot the 1 over 3 here, which they cancel. Okay? And then you have that it's x plus 4 divided by 3 plus c that I already have, and then we just rewrite it now that it's all clean, negative tangent inverse, and then I have x plus 4 divided by 3 plus the c. So this entire thing is your answer. Are we okay with that? That's what we have. Okay, so completing the square for this one, which is here, and then we need to do it naturally with u substitution, this part. Okay, let's look at the last one. Okay, the last one that we have for this set is truly beautiful. Okay, so you are like, oh no, it's so difficult. It's not. Okay, so let's read it together. Integral from 0 to root 2 over 2 of arc cosine of x divided by the square root of 1 minus x squared dx. So what I told you, that should be always your first shot to do u substitution. What would be the u substitution here? The u, well, I would do the arc cosine of x. So what would be the derivative of that? Well, on the previous lesson you learned that it was negative and divided by the square root of 1 minus x squared dx. Wow! Isn't that almost the same? The only thing that we need is the negative. Easy. I can put the negative there, right? That's not an issue. Cool. Now, you're going to change the limits of integration, which shouldn't be an issue. Why? Because you have the u, and you know your unit circle. So the lower limit of integration, it would be equal to the arc cosine of 0. You know that the arc cosine of 0 is pi over 2. Okay? And the upper limit is going to be the arc cosine of what? Root 2 over 2, which you know that this is going to be equal to pi over 4. Now, copy them on the correct spot. This is pi over 2 because that's the lower limit. I know that it's bothering you. This is pi over 4, which is the upper limit. And then we do our u substitution. Okay, so what do you have for u substitution? U du. Wow, isn't that nice? Now, before we take the integral of this, I would like to fix it. Okay, so you know that this is going to be equal, since we have the negative. Okay, we know that we can flip it, but now it's going to be positive. Okay, so you have that, which is nicer, right? After that, you can take the integral of that, which you know that it's going to be u squared divided by 2. Okay, evaluate it from pi over 4 to pi over 2. Okay. So after that, you know that this is going to be equal to 1/2 times, and it's going to be pi squared over 4, okay, minus pi squared over 16, okay, and you close it. You can just leave it like that, or I'm going to do it all the way because you know these are the notes, so I do it all the way. You know that it's going to be pi squared over 8 minus pi squared over 32, and this is going to be equal to 3 pi squared over 32, and that's going to be your answer. And that's pretty much it. I hope that you find this video helpful. Bye!